Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We had a sort of, I guess you might say a brainstorming session on Monday where we were trying to figure out what we wanted to do with respect to sorting our sprites, and my sort of cursory conclusion after having gone through it quite a bit was that it didn't seem like there was really going to be a simple, straightforward way to sort sprites. And like I said in that stream, I am not really a 2D game programmer. It's not what I tend to do. I've almost always worked on 3D games pretty much exclusively, except for like very rare occasions. And so the idea of having to sort sprites is not really one that I've thought through in any particular way. And so we're kind of trying to think it through now so that we could do something realistic. Now, I was hoping that it would be a relatively simple problem, but it seems like it's not. And one very interesting thing that happened over the break yesterday, because I didn't stream yesterday, was that Andrew Russell, actually, I guess I don't know how to pronounce his name. Andrew Russell, Andrew Russell, I have no idea. But I tweeted this out. He basically made a blog post for us because it turns out that he is working on this problem right now. In River City Ransom, which is, I believe, the sequel to River City Rampage. And he had actually been dealing with this and did a bunch of work to try and solve this problem. And the way that he discussed it made it sound like he did not find an easy solution either. It's actually relatively complicated. He sort of made a blog post that was like talking about the fact that I was asking the question, how should this be done? And then he was showing how he did it. And generally what happens is there's two fairly complicated elements to it. The first part of what he's doing there is they have a little bit more information with their sprites than we do. So for example, when you have a situation that like he's posted here, where we have three sprites that we might be talking about. I mean, there's other sprites back here, but just talking about these three sprites right here. Clearly we have a situation where you've got one sprite that's behind and one sprite that's in front of, and what they were kind of looking at is when these bounding boxes overlap, they actually have an idea of what the vox, sort of the three-dimensional depth of this thing is. And so they know what the bounding box of the sprite is at various z levels, or whatever you want to call it, going back into the screen in this case. And so that's one thing we don't really have. I don't know if we'll need it because even if we sort of did an approach similar to what Andrew is talking about, but if you look at this, because if you look at this right here, you can see they've got a sort of their isometric view is skewed twice, right? It's skewed both in terms of the tilt that Handmade Hero has, but then also a sideways tilt. And so that's a little more complicated in terms of what you have to handle, because on Handmade Hero, I don't think we ever really have the case so much where which side of a sprite you're on would determine whether you were in front of or behind it. Because you can see in this situation, you could have these two people at sort of equal layers in the scene, and one would be in front and one would be behind strictly based on which side of the sprite it was on there because of that isometric tilt. We only have that in one direction, and Andrew's got it in two. With the way that he's structured this. So that's a little bit of an issue because we don't really have much of a conceptualization there. But ignoring that for a second, because I'm not sure we have that problem. The second part is, I mean, I guess I would say he sort of decided to solve the problem by saying, look, this is a semantic problem. There is no real solution, so you can't approach it like a 3D thing. Which may very well be true. It certainly seems consistent with the way I was feeling about it on Monday. And so what he said is, look, let's just build the actual graph of what we think is in front of what. So we take all the sprites in the scene and we take what we essentially know about them, right? We say, we know that this should be in front of this. We know that this should be in front of that. And remember, I had sort of mentioned something like this on Monday, and I was saying, well, that's a little bit tricky because once you get into that situation, you don't necessarily have a single sort. And it's like that's exactly what he talks about here. And what he said was that's like, okay, let's just make the graph. And even though that graph does not have a single universal way that you could sort it, that's okay. We'll just break cycles in the graph by arbitrarily deleting edges, and if our arbitrary deletion of edges turns out to be incorrect, we'll start introducing heuristics to figure out, okay, let's be smarter about how we delete these edges. Right? So he goes through and he uses Tarjan's algorithm. Tarjan's algorithm? I have no idea how to pronounce that either. I don't really know how to pronounce most things. Well, you know what? Wikipedia will probably tell us. Nope, it won't. Never mind. He's using that algorithm to basically go through and find out about the cycles in the graph so that you can remove edges to produce a single directed graph that doesn't have cycles in it, right? It doesn't have cycles that'll break the sort. So that's how he tackled the problem. And, you know, I think there's a certain amount of attractiveness to the idea of just saying, well, you know, this is a very semantic thing, and possibly that the way in which we might want to state how things appear in front of or behind other things may never really be all that coherent, right? It may not be something that's really makes sense in full 3 dimensions in a way that can really be processed, and so maybe what you need is just something that deals with semantics, and then you just write rules for determining what those semantics are for any given scene, right? That basically says, I know this has to be in front of this, I know this has to be behind this, and you put enough of those out there, and then you can run a sort on it that will produce the correct sorter for the script for the scene that you're looking at. And I don't really have a problem with that. That seems like a pretty reasonable solution. It also lets us do some things that might be interesting. For example, let's say that we're going to output the sprite for the hero. You know, maybe we just want to say the head's always on top of the cape's always on top of the body, right? Before, we kind of had to address that sort of a problem by specifying z-values that would be higher than other z-values, or playing with the sort key. Remember, we had the concept of the sort key and stuff like that. And, you know, again, being a 3D graphics programmer, I haven't really thought too hard about what I might want to do in scenarios where I don't have sort of this more tangible definition of what's behind and in front of other things. But, you know, at first blush, it seems like a graph-oriented approach is kind of nice, because it does mean that I can just throw arbitrary semantic constraints into it that have nothing to do with where anything is. It's just, I know that the cape should always be over the body, or I know that the head should always be over the cape. I never want them to be drawn in any other configuration than that, right? So, you know, there is a certain attractiveness to that. I don't really know, again, because, like I said, I don't have a lot of experience with this kind of an engine. I don't have a strong sort of intuition about whether this is a good route to go down or not, but I did really like the fact that someone took the time to write in with a solution that they'd been working on, because it's kind of nice to know that if another person if another smart person basically looks at a problem and determines that it needs a relatively complex solution, that's kind of a good hint that probably, you know, there isn't some really obvious simple thing that we're just missing, right? The more smart people look at a problem and decide that something complex probably has to be done here, the less likely it is that there's a hidden sort of simple solution. Whereas if you're the only, you know, if you're the only person who's really looked at this problem, you don't know whether, you know, something complicated is really necessary, or whether you're just overthinking it or missing some special insight that would allow you to do something simple. Now, does this mean that there isn't, just because he and I both looked at this problem and didn't see an immediate obvious answer? No, I mean, there might still be something we're both missing, but again, I just feel like it's kind of nice to know that I'm not the only person who looked at this problem and didn't see an immediate obvious solution to it. So I feel like that's, you know, kind of a nice, it's nice to have backup, as I guess what I would say. A little reassurance that you're not just being stupid and missing some obvious thing that, you know, anyone else who came to the problem would just go like, oh, you just do whatever, right? So, you know, I would totally be down for doing a semantic sort here. And I don't really see a lot of problem with that. The main thing is that if we were to do a semantic sort, regardless of whether we did a similar sort of resolution to the semantic sort, we do have the problem that we are probably going to have to build our semantic sorts a little bit differently from how River City, what is it? River City Ransom Underground. River City Ransom Underground. I'm going to call that RCRU. How RCRU is doing it, because again, they're sort of tackling a slightly different problem. I feel like in some ways too, their problem might be a little harder than our problem, because like I was saying, when you start to have a second, the more axes you're kind of trying to fake depth along, I feel like the more complexity that you're going to have to deal with, right? So I don't really know that that's the case, but I feel like that's probably the case. And similarly, I think they're trying to get a lot more sort of variance in kind of how much can be sort of contained in a sprite in terms of height variance, whereas we don't really necessarily have as much of that. So I would suspect that we can probably get away with something simpler than what they have, which I hope is true because, like I said, I was kind of hoping to not have to augment our sprites with really any more information than what they kind of already have, which is an image, right? So there you go. So anyway, obviously, in case I didn't already say that, thank you very much to Andrew Russell for writing in, because I thought that was really great. And it was really interesting to read too. And also I kind of, as a separate total aside, this game kind of looked to me a little bit like Double Dragon, and I feel like that would be kind of fun to play. So I'm also kind of looking forward to the game. So I hope that's coming along nicely, because I kind of want to play it. Anyway, so that's the developments that happened yesterday. So I think I might try playing around with that now, just to see if I start to code something similar to that, just so I can get a feel for what it would look like in the code if that was what we were doing, and see if I can spot any obvious problems, or if I think I like the way it feels, so I can get a handle on how that would work, and go from there. So today's day 300 on Handmade Heroes, so you're going to want to unpack day 299 source code if you're trying to follow along with the programming at home. Now, let's do a little loading of the project. Yeah. So here we go. All right. So let's go ahead and try to take a look at some of this stuff. Now, the first thing that I might do is push the stack a little bit and say, well, let's hold off for just a second on the topological sort concept, because we sort of have a higher level sort concept as well, which is that we had those layers. And so maybe those layers as well, those could sort of be sort of packed into this sort in addition. So I might also take a look at that, I guess, as we kind of go through this, right? And so one thing that I'm kind of curious about, and I don't really know what I think about it yet, but I'm getting the sense, is that I feel like packing this into the render group might be the wrong way to go, right? So if the renderer, previously the renderer was doing the sorting, and it was doing the sorting sort of as its own conceptual thing that it did at the end of everything getting pushed onto the render group. And what it sort of suggests to me is that that might want to be a separate sort of system now, right? We might want to have a separate idea of how that works. And only because if you start to think about how this would work, I don't know that we want to bake all of that sort of topological information into the thing that's just supposed to be how we get things out to the graphics. And so I'm not sure. We may sort of have a case where we've baked too much down into a single place. I don't really know. That's a little iffy at the moment. Okay. But again, like I said, I'm not really sure what I want to do yet, so I'm just going to kind of start playing with this to see what I think would happen here. So let's go down and take a pretty simple scenario, like something that's not, again, like maybe something very, very straightforward that I kind of know is the case, which is that, I've got sort of this notion of these, where are we here? Of these pieces that I'm rendering. And maybe I want to start talking about the how the pieces... Why am I not seeing the iterator for those? Is it called something else? Oh, right. I know why. I made the same mistake before. The piece iterator is actually on here. So when I come through this this piece index stuff, right? What I could do is have some idea of, for each one of these pieces, how they're supposed to fit together in terms of sorting. Because that's almost always going to be the case, where like every sort of creature that I create, probably the pieces are going to want to have a particular piece of sort information sort of going with them, right? And especially for things like, articulated bodies, we kind of just know we want, for these 2D sprites to layer on top of each other the way that they were layered, in the Photoshop file they came from or whatever else. So if we take a look at this piece index stuff, we could imagine looking at this here and going, well, when we do this push bitmap, maybe in addition to just pushing the bitmap here, we would also say, hey, this bitmap always has to be in front of this other bitmap, or this bitmap is, whatever, right? Something like this. And then we could know that the people who do the piece things could just store which piece index they were in front of. And if that piece index is, your own index or something like this, then you know that you're not in front of anybody. If it's an other index in the array, then you know you're in front of that other thing, whatever it is. So that's just an example of something that we probably could do. It would be really simple to do here. And so that, I think, would solve the problem of inter-piece sorting, certainly, because we know that they always go in that order. Now, the other question that I have here is, all right, so let's say I'm outputting these pieces. How would I know how these pieces sort relative to other things, right? And that, of course, is another question. I guess entities are sort of output by themselves, and so what we would have to do is, in order to figure out how an individual piece that doesn't have a particular piece of information about how it fits into the scene, which I guess normally they wouldn't, because they're only going to have information about how they fit with each other. I got to go ahead and figure out what the rules are for what goes in front of what, right? So let me go ahead and try to enumerate those in as much as I can here. Here's day 300. These are our sorting rules. So I guess my thinking on this is we have a number of cases and we should just try to enumerate them as best we can, right? So I think what I would say is we know certain information about planar. So we kind of have this notion that we've got sort of two types of sprite. We have the ones that are on the Z plane, and then we've got ones that are on the Y plane. And I think that's basically all we have at the moment. So if you think about those, what we would have is, here is our coordinate system, right? Oops. At the moment. So that's what our coordinate system looks like. And so the sprites that we have are sprites that are on the Z plane. So, something that's lying flat. And since we're in orthographic, it would look like this. In perspective, it would have looked like that, right? These are things on the Z plane. Their normal is Z, and they have a Z sort, right? And then we have things that are in the Y plane. So this plane, and their normal is y, which faces kind of right out at the screen, right? Although it's not quite right at the screen, it's tilted a little bit. It's since it's that way, right? So we've got those two types of sprites. Those are the two kinds of sprites that we have, and we really just don't have any other kinds, right? A sprite has to be categorized into one of those two, and I don't anticipate really allowing at this point anything else. So if we then take a look at these sprites and we see, if two sprites, and this is kind of another thing that I think we have to admit, and looking at what Andrew posted, I think reinforces this in my mind anyway. One thing that I really wasn't doing before, or really wasn't thinking about carefully enough, was the fact that obviously to start with, we only care about sorting sprites if the sprites overlap each other, right? Meaning, it doesn't matter what order we draw two sprites who aren't overlapping. So to the extent that we care about what happens to those sprites, it's only in terms of how our sort order goes, right? How our overall sort order goes. So in terms of determining the rules we actually care about, we only need to know what happens when two sprites are overlapping, right? So, okay. So let's talk about this for a second. So we have, if these are the kinds of sprites that we are going to support, we're going to support z-planar and y-planar sprites, then by definition, in terms of overlaps, we have four sort of nominal cases, right? But we can simplify that down to three because one of them is interchangeable, right? We have z overlaps z, we have y overlaps y, and we have z overlaps y, right? So this is like z-planar sprites overlapping z-planar sprites, y-planar sprites overlapping y-planar sprites, and then one where it's a mix. And technically we have y overlaps z as well, but because there isn't really a meaning to the ordering of who is overlapping who, I mean, two things that overlap, since we're talking about sorting, there isn't a concept of who's like in charge here, right? So the z overlaps y case is the same as the y overlaps z case, which is why I say we technically have four cases, but really there's only three that matter because y overlaps z can just be treated as z overlaps y. You just switch the order of the two things you were checking if you got that case. So these are the cases that we have. Now, if we have a z overlaps z sprite case, in that case, so let me break. I guess what I say is let's break these down one at a time and figure out what we want each case to be here, right? So let's take our first case, which is z overlaps z. Okay. Now for z overlaps z, we have a situation that looks something, like this, let's say. Okay? So both of these sprites are basically, right, they are, parallel to the concept of the ground. And we need to sort these things so that they come out properly, right? Now, if we were only talking about things that were directly on top of each other, then presumably it becomes relatively straightforward to sort them because we would just sort them by z. So, if two, looking from the top down, if the answer here was that these things are right on top of each other, we would only care about sorting them by z. But if things are sort of offset in y as well, we have to think about this problem a little bit harder, right? So let's talk about this a little bit more carefully. So in order to get something that looks like this, one thing that I think we could say is that if we sort these by z, and in fact I think I'm trying to think if this is incorrect or not. Well, let me keep talking because I was kind of trying to jump to a conclusion there, and maybe I shouldn't. All right, so we have some different cases about what's going to happen in the y and what's going to happen in the z. So I'm just going to again enumerate all the cases, and we'll just see how it shakes out, right? So if we take a z overlaps z case, then we obviously have three things that could happen with their z coordinates, and three things that could happen with their y coordinates, or I guess four technically, right? So if we take a look at the coordinates, we just look at one of the axes, right? We would have, as I think I drew out before, we would have a disjoint case, right? So they look like this. And maybe I should draw these a little bit offset so you can kind of see. So there's the disjoint case. There's the overlap case, right? And then there's the subsumed case. Right? And you can think of this as happening in either dimension, right? So this could be happening along the z-axis. This could be happening along the x-axis as well, right? Because technically these things can be could be considered bounding volumes. So the sprite can have a certain depth in z if it wants to, right? You can sort of have that as a conceptual z depth, if that makes sense. So yeah, so. Trying to think of what that sort of means. I guess no, that's not really true. So, since we're not really allowing you to have... I'll have to think about that. I'm not sure to what extent we want to allow things to have both, as opposed to just breaking them into two sprites. I think what we would always do is just break things into two sprites for the most part, right? So for example, if we were to have a block that looked like this, right? And here's like the side of the block and here's the top of the block. I mean, I think we would want to break it into two sprites. Like this is the one sprite and this is the two sprite. And this one is a Z sprite, right? And this one is a Y sprite. I think that's how we would want to do it. If you could stand on it. If you couldn't stand on it, we wouldn't need the Z sprite part of it at all. So I think we might be able to get away with not really having the concept of depth at all there, right? So for Z sprites, it would seem that since they are always flat slices, for all intents and purposes, you can sort them directly, I think, based on their highest Z point. Like they'd just be whatever that slice is, it's just constant, right? So I think we could say that this is the case for Y. But for Z, there's really only two cases. There's coincident and not coincident, right? There's either they're right together or they're askew. All right. So let's think about this for a second. So let's say that these two things are overlapping on the y-axis, but let's talk about this z sorting here. So if something is higher than something else in z, then that means that it's sort of on a different plane. And if we assume that it's always going to be a flat piece like this, that would seem to suggest that you could always sort those things just sorting them by z, right? It's always sufficient to sort z-planar things by z. There'll never be a case where something that's below something else in z should be drawn first. I don't think that would ever actually occur, right? Because no matter what you did, I don't think you could ever really produce the case where, like, I'm trying to think if I can ever produce the case where something that's lower in z actually draws on top. Because as things, as you tilt and things kind of go up in y, they're going up in y by getting a higher z value. If they have a higher z value. So you could never get lower by having a higher z value. Ergo, higher z value always increases your visibility on the screen, never decreases it, as far as I can think, right? So I feel like sorting by z would always work for z sprites. I don't know. So it seems to me like maybe sort by z just kind of works in that case, and you don't really have to worry about it at all. I don't know. That's just my thought, but I'm not sure. So I feel like sorting by z for a z overlaps z sprite would be a fine rule that would just kind of work. For y overlaps y, right, I feel like basically the same thing is probably not. I feel like we're not going to get away with something so simple, and the reason for that is that the z value of the sprite could influence how it's supposed to be sorted. So let's take a look at that case a little bit more carefully for y overlaps y. Maybe what we should do, in fact, and I'm going to see if this is true, but let's take a look at a y overlaps z first, because that may be the easier case even. So here's case 2. Here's case 1. All right, so for a y overlaps z, that's the case where we have like a z sprite like this, and then we have a y sprite like this, right? And we need to know which one of these we should be drawing. So I would imagine that in the case where we're drawing these, what we want to know is the highest point on the y sprite, right? Is the highest point on this y sprite going to be above this z sprite in the case where the y sprite is actually overlaps the z sprite in y, right? So for example, what we would kind of have to know here is how big is this z sprite in z, right? So if we were looking at, I'm sorry, how big is this z sprite in y? So if we took a look at the top down, right, here's the y-axis, here's the x-axis, z-axis is kind of coming out at us. So if we were to look at this, if this sprite is behind this z sprite in y, I feel like there's no way that this sprite should ever be drawn in front, right? That's just nonsensical to me. Same is true, I think, for if it's in front of, right? So if the sprite that we're talking about, if the y sprite's y is entirely behind the z sprite or entirely in front of the z sprite, then you can just sort by y, I think, and be done, right? Because there's really no case I can think of where that wouldn't be true. Yeah, I think that's always the case, right? So the only question comes when there's an overlap. So I think the first thing we say is if overlaps in y, then we need to do the complex case, else sort by y, right? So if we overlap in y, and I shouldn't say overlap, I should say something a little bit more specific. If y inside y range of z, right? If the y sprite is inside the y range of the z sprite. If that's the case, then we have to figure out how to sort these two things more conclusively. And I guess the easiest way to say that would be then we would say sort top of y sprite by z, right? Because if this point is above this sprite's plane, we should draw this guy, and if it's below, we shouldn't. I think it's that simple, right? And if we wanted to allow you to interpenetrate, we would have to split the sprite in half at the point where it was penetrating. But we're really not going to allow interpenetration, I don't think. So at least I don't anticipate allowing that. I think if we were going to do something like a creature that kind of rose up out of the ground magically, that would be an effect that knew about that, so it would already be clipping. It could just know to clip to it where it was coming out of the ground. So I don't think we need the sort to compensate for that. I think that can just be handled manually in the cases where we want that, because we're already going to have to manage that as a real effect. So let's talk about number 3, which is y overlaps y. So if y sprites overlap each other, Then we sort of have, I guess, I think this is the most complicated case. I don't know, I could be wrong about that, because these two cases are pretty straightforward. But if y overlaps y, then what we have essentially, looking at it again, sort of from the perspective of top down, we basically have something that looks like this, right? So we've got these two sort of sprites, we're looking at them, and they've got a sort order in y, and on the screen they look something like this. Now the only question that there is how, can we just sort them in y, or do we have to do something more complicated here? And the reason that I don't know if we need to do something more complicated here is because I feel like there's a z component to this sorting that is relevant. And the reason that I think that's true is because, for example, let's say we took the hero. So there's the head, there's the torso, there's the body. In this configuration, head sorts top, torso sorts middle, and body sorts last, right? Cape sorts middle, and body sorts last. If that's the case, then what that means is we need sort of this idea that the z stacking of y sprites makes a difference, right? So I think what we would need to know there is how do we interplay the y and the z properly to figure out whether you're in front of or behind someone based on that z value. Because yeah, obviously, increasing the z value of a sprite that's clearly behind another sprite shouldn't sort it in front, but then at the same time, we kind of have this weird thing where the capes are, in front of the hero and whatever. The answer might be that you do always sort in y, and this is a special case, so things that are assemblies have to be specially given those rules specially, right? And that would be fine. Like I said, we could just have that be a thing that happens. So I don't know, maybe that's not a problem. I don't know. I would say that I don't have a real case in mind. Like, I wish I had a clear case in my mind that's like something that'll happen in the game that involves sort of not a known assembly, right? Because what we're talking about here is sort of, I want this one known assembly to sort like this. But if that's the only time that this sort of thing ever happens, then that's probably not, there's probably no reason to lean on the topological sort. We just throw these things into the sort as a unit that just always goes in the direction it goes, right? It's like, hey, these things are just sorted together and then make sure they go on top of each other like this. That would just work, right? In other words, we could treat them all as just one sprite effectively at that point and not have to think about that too hard. So I don't really know if there's another case where I actually wouldn't be able to sort by y. So it's possible that the answer here is like you just sort by y and you're done. That they just have to be in front or behind each other based on their y values, and that's always correct. Because I think that might always be correct. So yeah. So if you take a look at what actually happens here, if we consolidate these cases and write that down and assume that we're correct at all, which we might not be, we have like z, a z-z pairing is sort by z. A y-y pairing is sort by y. And a zy pairing is sort of a question mark, if you will, which is y in z, and if it is, then we sort by z, else we would sort by y, right? That's what we said, I think. if y overlaps in z, sort by z. And there we go. And z is always the top z. So like z is always highest z. And y, sorting by y in this case is always just a known thing. So if we look at what actually happens here, essentially we always fall into one of two cases, a sort by z and a sort by y. That's always true. So really we just have a preamble which says, how do I pick, you know, what I'm sorting by? And in this case, we could say that this predicate here, the y in z predicate, we could say that this predicate is really the entire determiner. So the entire thing is, we would say, you know, if, you know, y in z, whatever that means, we would say sort by z, else sort by y, right? And this function here is just our cases. So the y and z case is like, you know, is it z on z? If it's z on z, well, I guess I'll draw it this way. In the case where we have a z on z case, we want to sort by z, so it would return true. Is it a y on y case? Then it would return false, right? And then because if you think about this, y on y sprites can never overlap, right? That's not possible because they don't have any z depth. They can't overlap in z. So that is actually the case, that's always false. If they did, they would be in an illegal case which we can't resolve anyway, right? And if it's a z, if it's a y on z case, you know, then in that case we have to check the actual bounds. So really we know we're always sorting by either the y or the z, and then we have, again, that sort of concept of like we've got to check the bounds at that point. This seems plausible to me. I feel like I'm okay with that. You know, I feel like that's reasonable, and I feel like there's enough wiggle room there too, that we could basically say that, like, okay, suppose, you know, we came up with some tricky case that we're having trouble with. It feels like we could add special cases into a system like this relatively easily, and that seems like kind of what you want, because when the system looks like it does with these two sort of 2D plus some 3D kind of engines, it feels like you want to have that concept of a sort that can support weird stuff getting thrown into it. Like, hey, I know it's weird, but you got to use this crazy sort rule. I feel like that's a good thing, because that allows us, I think, to special case stuff in times when it's like clear that something you know, needs to get resolved that's just kind of semantic and weird and doesn't have a lot of physical analog to it potentially, right? So that seems pretty good to me. And if we wanted to, I feel like we could do a sort there. I feel like we could do a sort there where, I don't know, we could almost try not having something that does much conflict resolution. Hold on a second here. Like, for example, if we were to do this, does this produce a total sorting? Right? Would be one question. And And I guess the problem is we don't know what would happen if the things are disjoint. Although I guess we do. So we are kind of fully specified here. So the only question is, can this produce cycles? And I don't know if it can or if it can't, right? Obviously, this is the thing that would produce the cycles, because if we always sorted z's on z's or y's on y's, then obviously the sort is complete. So the only question is what happens when we start to get those intersecting people. Are there times when we would pick that one thing sorts on either side of another, right? So let's say we've got two things that overlap. So we've got two z's and we've got a y that overlaps them both, right? This is the kind of thing where we would have, here's two z tiles and we have a y that overlaps them both, which is a pretty common thing that would happen, right? So is there ever a case that the sort would not produce the sort that we would expect it to produce, right? And that question seems like it doesn't seem super plausible. I don't know, but let's think about this. So let's say that we raise this sprite up to here or whatever. Well, I've got to keep it overlapping. So they're still going to overlap, right? In theory, even though this one might be considered a little higher. Although I guess, strictly speaking, that's not technically possible. And either way, in both cases, this guy would sort in front of, so I don't think that affects... Yeah, I don't know. I guess we should try and figure it out a little bit more diligently, but I don't know if this always actually, for our cases, produces something we could sort on directly, if that makes sense. So it may be that we don't really have to worry too much about even doing a full topological sort. We could, or rather, I guess a graph sort, because we may be able to just still do this by an item comparison sort that is a partial ordering that will produce correct results in all the cases we care about. That would be nice, right? So let's say that we were going to do something like that. If we were going to do something like that, when we throw these pieces into the system, again, like I said, the main question here is, should that be in the rendering code or shouldn't that be in the rendering code? It seems to me like maybe that should not be in the rendering code. I don't know. Like we maybe want to stop having that sort of sorting stuff happen in the rendering code, and maybe it should happen kind of as a separate layer that sits on top of it a little bit. I'm not entirely certain, like I said, how that should go. Because if you think about the information that has to be stored here, essentially what you need to store is a y, min, and a max, and a z value. I don't think you need the minimum z value for anything in particular. It didn't look like any of our cases were going to matter much about what your minimum z value was. So it seems like we only really care, as far as I know, about having y, min, and max, and z. And the z would be the maximum. So your max z, your min and max y. And then with that information, you can sort everything. Far as I can tell. Well, let's take a look. So if we were going to do that, when we have our entries here, let's see here. Here's our headers. So when we have our render entries, which all get sort of entered into here, our sort keys, which I think are used separately, where do those happen? Where's our sort? Is that in the platform layer? There we go. No? Where's our sort entries? I don't know where they are. This is the problem with having too many code bases in your head at any given time. You start to forget things. There it is. So these things where we kind of have a sort key and an index, the problem is here, right? We would not be able to use the same sort that we were using because it would need to be more complex than that. Now that's not a problem, right? We can create another sort here that's does it a little bit differently. So let's say we have we take this merge sort here, right? Because we can't use a radix sort anymore because there's nothing to radix sort by, right? There's no way to construct a single value that you would use to do your sorting. But if we wanted to, we could do a merge sort still. The merge sort's fine. So we could do a merge sort, and this is for a, I guess a sprite bound. Something like that. I don't know what this is. That was kind of an aborted attempt. There we go. So if we take a look at this guy here where we're doing our merge sort, the merge sort is now going to basically just be the exact same piece of code here, except when there's two places, right? Here where we do our basic comparison between two items, and here where we determine whether or not we need our merged items to be placed in front of or behind each other. These now have to be sort of, these have to be described in a way that is more complicated. It's not just taking two values and comparing them. We now have to actually implement the sort rules as we talked about using more elaborate data. Now the first thing I'm going to do is I'm just going to swap the sense of this comparison so that they're both going in the same direction. I don't really know why I didn't do that to begin with, but what can you do? So in this situation you can see here, right, we've got the same comparison done both times but on two different things. And so what I'm going to do is just introduce a thing here that's like, here's my comparator, and it's going to return either true or false, whether or not I should do the case, since they're both the same. And so what I want to know here is, who should sort in front of who, I guess, if that makes sense. And in this case, like we're saying, we're going to put entry A and entry B in order. And we swap them if this comes back true for entry B. So this is like in front of. So I'm just going to name it that, is in front of. And then we'll have sort sprite bound A and sort sprite bound B. So I'm just going to say, like, okay, if is in front of, then we need to swap these two guys. And the same is true here where we say if is in front of. And that's really all we need to do for our sort. Now we just have to implement the rule, which is to say that in here where we do sort sprite bound, we need the things that I talked about. So this is a ymin, a ymax, a zmax, and then our actual index. So still not too big of a thing to sort, so that's good, because we don't want these to be particularly large since we're moving them around, potentially. So it's still something that is, what is it? It's 16 bytes long. So that's not a bad thing. That can be sort of romp written by the CPU in an easy copy fashion, which is, I think, probably what we want. So things we're going to be sorting a lot of. So how do we determine this? Well, I wrote out very explicitly what we were going to do here, right? And so in these cases, I think we might be able to get them down to just looking at these numbers a little bit more directly with the ymin, ymax, zmax, right? So because what we would know is that the ymin and the ymax for a y sprite are going to be equal to each other. So we would know ahead of time whether or not something could be inside of, like we can just test for equality of those two without storing which kind of sprite this is. Right? And we can probably simplify the math down as well once we get it. So I'm going to write out the cases explicitly without being too clever, and then we're going to probably be able to collapse them down into something even better, right? So, all right, let's do the first thing, which is to say, what are our cases here, right? We have if y against y, else if z against z, else our final case, right? So we know if we have a y sprite, and actually, you know what? I could do it this way. If sort by y, else not, first of all. So we know that there's only two cases that we're ever going to actually process by, sort by z, sort by y, right? I'll do it the same way I wrote it in the code. So let's say, for starters, that we have that, and we're going to equal that to something that tells us which one to sort by. If we're going to sort by z, then all we really need to do is say, well, whatever the result is here, and in fact, I could even just roll this into this is a very simple ternary. I could just say, well, if we're supposed to sort by z, then we'll do the z comparison. If we're supposed to sort by y, we'll do the y comparison, right? So if we're sorting by z, then what we want to say is we're comparing the z maxes. We want to see if I'm going to be in front of you, then my z max should be higher than your z max, right? And then for sort by y, what we want to say is whatever the y, again, is kind of going back into the screen because of the way that we've got that arranged. So I want my ymin to be less than your ymin, right? So I want to say my ymin is less than your ymin. That would determine whether or not I'm closer than you to the viewer. So that's a pretty easy way to return the result here. So really the only thing that we have to do is write the slightly more complicated code. That is, how do we determine which one of the cases we're actually in? Are we in a sort by z case or not? And so if we take a look at what happens in our thing here, we said, well, the cases where this is true, where we're going to do a z sort, is if they're both z sprites, right? Or if they overlap in y. Because that's the, if they don't overlap in y, then we're going to sort by y, right? So if both of these are z sprites, then if both of these are z sprites, then that would mean that their y min and maxes were equivalent, right? So one case for sort by z is like both z sprites. And both z sprites would be like a y min equals a y max, and b y min equals b y max, right? So if they're both z sprites, I would do it. The other case is a includes b, and the other one would be b includes a. So the sort by z is just if they're both z sprites, or a includes b, or b includes a. In any other case, we're going to sort by y. So a includes b is pretty simple. A includes b if it's y min, excuse me, and I guess technically if I wanted to be a little bit more, well, let's keep going with this. If a includes b, if b's y min is greater than or equal to a's y min, and b's y min is less than or equal to a's y max. Similarly, the same would be the exact same thing would be true if these were reversed. Right? And so the question that I was having before is, or at least the thing that I was thinking about, is in the case where I have, I'm wondering if this can be kind of just simplified fairly drastically, like I was kind of saying at the outset. If I know that my ymin and my ymax are the same value, then there's no way that I could include. And in fact, I could make this more dramatic and say, okay, now there's literally no way that a y sprite can ever include anybody else because it has no actual y range. Only a z sprite can include, right? So at that point, I would know that if they're both z sprites, I should sort by z. If A includes B or B includes A, I know these will never be true in the case of y sprites. They can't include anybody, right? They can never include anybody. So I think, let me just think this through here a little bit further. I think we could probably, well, no, maybe not. Technically, it's time for the Q&A, so I should probably stop. But I have a feeling that if we actually look at what happens here with the math, I think we could probably get to a point where this actually simplifies much further, if that makes sense. I'm going to do a little compile here. What is the thing? It says error, missing semicolon. Right you are, sir. Oh, wait. Are you? Right? There we go. And entry A, entry B. Swap cannot convert one from swap. What does swap do? Here's swap. So we need another swap. There's our swap. And then again, if you're okay with templates, that was something you could templatize. They're the same, right? The swap is the same in both cases. So there we go. And then tomorrow we can take a closer look at that. The size of, isn't it y vertical sprites that have ymin equal y max? Yes, it is. Oh, yes, sorry, you're totally right there. So this is actually both y sprites, not both z sprites. So that is my bad. Right? That's what that should be. Thank you. You always do equals for float comparisons. How can you ensure those will ever return true because of float precision? This may be something that I fail to mention a lot of times, and that's probably my bad. I don't think about it that often. But the reason that I can do that here is because I know that I'm setting these values, not computing these values, right? So if I'm computing values with a floating point calculation, then that's a case where you have to be aware of what the tolerances are for the computation. Because if the computation has a spread that it could produce, you can't test for equals. And so your intuition is very correct there, and that's totally true. But if this is a case where I'm setting the y values myself, then I might know that there's cases where I set them both to the same thing. So in the case where I record a z sprite, I'm going to set ymin and ymax equal to, I'm sorry, the case where I record a y sprite, I'm going to set ymin and ymax to the same value. If that makes sense. So I know that they'll be exactly equal, not approximately equal, and therefore I don't need to think about a computation epsilon. And so, yeah, when you see me write actual equals there, that means I feel like I'm setting these to exact values, not as a result of a computation that could be variable. In the y overlap z case, what about cliff sides that are holding up the ground sprites? So elevated ground isn't just floating there. Would that cause an issue with anything? So what I was sort of saying before is I feel like we can break up sprites that are problematic into two pieces. So for example, if I've got a cliff side here, and here's the top of the cliff, and here's the side of the cliff, right? We could break these up into two sprites if we needed to. However, that said, I don't know that we actually need to. And the reason that I don't know if we actually need to is because I think, since no one can stand on the side of this thing, it might actually just always work, right? Because it's always going to sort in Y behind anything that's out here, I think. Right? Because anything that's here, its Y value isn't going to be intersecting this guy, right? It's going to be in front of it. So I think it's probably okay. But like I said, I'm not too worried about that case because I know I can split those sprites very reliably at asset creation time even. So it's not like a thing that has to happen in the sort. So that special case I'm not too worried about. M. Van de Vander. I literally did the float equals thing last week and considered it acceptable for that exact reason because I was just checking if a value had just been set by me to an exact value on the previous frame or whatever. Yes. So the important thing to remember about floating point numbers is that floating point numbers are still just integer numbers, right? At the end of the day. They're not actually magical. They're just a way of taking an integer and knowing where it lies on the number line. I'm sorry, on the decimal point, right? That's all it does. And so they still have concrete exact values. And if you know what your computations are doing, you know whether those values should be equal or not. Certainly on Handmade Hero, and generally in my programming career, I don't tend to analyze floating point algorithms to the degree where I have any idea what their values will be at that level of precision if I didn't set them equal to something myself. So typically, you treat them as having epsilons for most computations because you haven't analyzed the computation to the point where you have any idea about what the actual range really is, right? But that doesn't mean that it doesn't have an exact value that it does come out to. You do know what it's going to be, right? You know where the round is going to happen, you know all that stuff, and it will be an actual value at the end. The problem is just, are you ever realistically going to analyze your things and have opinions about that stuff at any fine-grained level most of the time? No. But when you do set something to an exact value, it's not like it can be some other thing. It still is an exact bit pattern, and you can check that exact bit pattern on both sides and know that it's going to be equal. Any more Q colons? Any more Q colons? Any more Q colons? Any more? All right, looks like we've got no more Q colons. So I am going to go ahead and close it down. Okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, you can do so by pre-ordering the game on handmadehero.org. It comes with the source code, so you can go ahead and play with it. We also have a forum site. That forum site is a good place to ask questions. We have a Patreon page where you can support our lovely video series. We also have a schedule bot where you can tweet the schedule, or rather, you can have the schedule tweeted to you so you know when we're going to be live. And we have an episode guide if you want to catch up on past episodes. Check them all out. They're great buttons. They're the kinds of buttons that just make you happy to push them. That's about it. I will be back here tomorrow, 5 p.m. Pacific Daylight Time, for more programming where we will see what happens with our new sort. Or, well, that may be presumptuous. We will finish the coding of our new sort, but that will probably take a while because we have to sort of get the render pipeline organized for it, which is going to take a little bit of moving stuff around. But we should have our new sort implemented. We may not get to the point where we can actually that we're actually debugging it much, but we're getting close. That is it. I will see you tomorrow for that. Until then, take it easy, everyone, and I'll see you on the internet.